All right. Well, welcome to anybody who's watching, either now or in the future. Hello, future. Yeah, they're going to find out real quick that I'm a nerd. All right. So let me go ahead and stop sharing so you can see everybody. So I'm Eric Gross, and I'm joined here by Carolina Correa and Brandon Mitchell. Say hi to anybody who's watching.
Hello, everyone.
All right, so we're a group of developers. Some of us more senior, and some of us a little more junior, and we all kind of have a similar viewpoint, which is that when you're looking at some of these tutorials on YouTube and other sources, they all just seem to go perfectly. Everything's perfectly curated. There's never any bugs, any mistakes, and when you try to do the actual tutorial, it never works out that way. And so we figured we'd actually go through the whole process of building a pretty representative application, but encountering all the stuff you really do encounter. And along the way, kind of just show people what the day-to-day work is like and what the cadence is like of one person contributing from one point of view and another one from another point of view. We'll include some of the design aspects that you do at the beginning. And we kind of envision this lasting between 3 and 6 sessions, just till we get to the point where we've learned some stuff and we've helped people. So from now on, we're primarily gonna just communicate with the, with each other. I'll be paying attention to chat as much as I can, but just be aware that we're really trying to just show what it'd be like to actually do the development. And best thing to do is just follow along. When we get to coding, fire up your code editor and do the things we're doing. And finally, all of these broadcasts will be saved to my YouTube channel about 24 hours after we're live. And so you can always watch it again, follow along, pause it as you need to. All righty. You guys want to get started?
Yes.
Ready.
Okay, cool. So I kind of figured I want to start just documenting what it is we're working on, how it's put together in a document that will kind of be a living document that's going to stay with our project. So it'll be a work in progress, documenting our thoughts. It'll eventually probably end up having, the system diagrams in it and details on, features and that sort of stuff. But let's start with that. So I'm going to share my screen. I'll start this off. And I want to make locally a project where I'm going to put everything. So I'm just going to open a new folder. I'm going to go to my repos and make a folder just for this. And we're going to call this, let's see, we are Learn in Public MERN. I think that's a perfectly fine name for the folder. And in here, let's just start our README. Got markdown. And I think we were talking the other day, have either of you used this markdown syntax very much?
No, I have yet to make a README file.
Okay, cool. So you guys will both be contributing to it as we go along here. So you'll get familiar with the basics of the syntax. There's nothing super complex about markdown, which is by design. And literally, if you Google basic markdown syntax, you'll get great references, easy to understand. So we're just going to call this at first design notes full stack MERN app. If I can type. And we kind of just need to think up a fictitious situation for why we would be creating this full stack application. And I know we were all talking the other day, the kind of application that we build is a lot less important than just building a fairly representative full stack app. So what I kind of thought we'd do is say the situation is this. We have a typical modern retailer. We have internal customer service reps. They take inbound calls. and place orders for customers. They need an app to do their work. So often when you're building something, you're computerizing what was up to that point a manual process. So let's just kind of play pretend of like, let's say this company had been around for a while, but didn't have any sort of a tool like this. And let's go, that's 2 hash marks, by the way. The single hash mark up here on line 1, that's a headline of the largest size. Just like in HTML, you have your H1, H2. It's the same sort of concept in Markdown. So this is the second, size, 1 size smaller. We'll put down existing manual process. So this is what our CSRs have to do right now. And again, I'm going to ask for your thoughts on what they might have to do. But let's just say that right now, CSRs are manually doing the following. So pretend you're a CSR. What do you think they have to do when they get a phone call?
Get the name, information, address.
Okay, good. So get bio info for customer, name, address, phone, that sort of thing.
Sure, yeah.
So let's say it's an existing customer. They just need to identify a specific customer that already exists. So they can ask them like, have you ordered from us before? If the customer says yes, and we don't have any, one central computer program like this, where do you think those kind of records would be kept?
Where?
Yeah. What kind of tool would they be using if they didn't have a nice, beautiful little computer program that we're going to build?
Excel spreadsheet.
Bingo. So really, first, the thing they're going to do, check if existing customer, right?
Mm-hmm.
So we'll go if put a yes, look up customer details in Excel. Ew. Okay, good. So what if no?
Register.
Yeah.
Yeah, recreate an account.
Mm-hmm.
Enter customer details in Excel. So let me ask you a question. Let's say the customer last ordered from us like 3 or 4 years ago. And honestly, let's say they actually don't even remember what they've ordered from us specifically. Let's say we sell a pretty common line of products. And they say, I'm not sure. And they give you some name and you do this thing where you look up the customer details and you don't find anything that matches. And so you go through this and you make a customer. But let's say they in fact did order from us 4 or 5 years ago and their name was slightly different or it was entered wrong. Now we have 2 records for one identity.
Mm-hmm.
And now we have a problem. If we wanted to do some sort of analysis of the number of customers we had, we're off by 1 already because that's the same person. What other problems do you think would arise if there are 2 identities in the digital records, but they only refer to one actual human being?
It will be a duplicate. So, we'll just like possibly generate 2 invoices or something like that.
There could be that. Brandon, do you have any thoughts?
Not beyond what Carolina said, really.
Okay. Let's say we were wanting to, we've been in operation for a number of years, and we really wanted to do some sort of an analysis from a marketing standpoint of what our best-selling items are, what demographics prefer which products and that sort of thing. when we go back and look through all of our customer data, our data is wrong to that degree.
Sure.
Now it's a minor impact, but it's wrong.
Yeah.
So that customer wouldn't have anything. But now let's get very precise. Let's say that for a specific customer, we had this sort of customization thing. When they log in, we want to make recommendations to them based on what their order history is, things we think they might want to purchase.
Sure.
How do we get the right data when an order is split across two different identities in the electronic system? Now we have a problem. You see it?
Yeah. So what you're saying is that we need to merge those accounts?
Well, yeah, and more importantly, this choice to actually register a new client, this is down the line, but we need to start thinking about when we actually code this, what precautions can we put in place to at least try to prevent this? For example, when they search for a name, how loose of a search do we do to find possible similar identities? Like if someone's last name is Thompson, I'm reminded of this really nerdy comic I read when I was a kid called Tintin. It's from Europe. And there were these, it was this smart little boy and his dog who, well, was a teenager or whatever. And they've gotten a lot of adventures, but there are always these two cops chasing them. And they were Thompson and Thompson, but one of them had a P in his name and one didn't. And they would constantly fight about it. Stupid. But it's a very real problem in data quality.
Sure.
So if we build the search for a customer, like we see on line 17 here, we just need to think about, we're going to have to make that a bit of a loose search and find possible matches that are kind of like what we're looking at instead of an
Would you
exact match.
define loose search? What do you mean by
Yeah,
loose
like
search?
a loose search would be where you are looking for text patterns, because that's all a search is most of the time, is a text pattern where the arrangement of letters is not a perfect match, but parts of it seem to match.
Sure.
And there's ways to implement that technically, right? And quite frankly, rather than reinventing the wheel, when I need that, I almost always find some pre-existing library that does that for me anyway. Okay. But part of the reason I'm having this discussion is that when you're sitting there kind of planning a project like this, someone in the room might bring up what I did. And you have to capture that thought. So what I would do is go down here and just start a little thing here called design notes. It's just, who cares what you call it? I just want to make sure we don't lose that valuable thought work that all three of us kind of went through. Right. And so I would say here, loose search for customers. And I put here, try to prevent duplicate entries. And we don't need to, we can just forget about it. We documented it. I can even just push it off the bottom of the page, and our context comes back to what we're doing right here. But this happens inevitably when you're sitting here in any kind of a planning or brainstorming session. Someone's going to think of something that actually is valuable, but not right now. So you got to capture it. Cool.
Sounds good.
Okay, so now let's go back to this whole thought exercise. We're pretending we have a real company and that people are doing all these things manually. So the CSR has got Joe Blow on the phone, and Joe says, no, I've never ordered from you. And so the CSR says, okay, and opens up the Excel form and goes, okay, I need your name, I need your address. So we don't need to capture the exact details. There's typical things you'd always want to know about a customer, but that's what they do, right? Mm-hmm. So now what do they do? They've got the person on the phone.
So is the person ready to order?
There you go. You ask them. Absolutely. Okay. Good. So if they want to order, then what do we do?
Check the inventory.
Well, first we need to know what they want to order. Get the desired product.
Mhm.
Okay. Now, no customer is ever going to know your inventory and product line as well as you do. That's not their job. Let's say we sell something that has a huge number of very similar products, like screws. You buy little screws, right? We need to make sure we get the right thing. So if we didn't have a computer program and the customer says, I want to buy a screw, what's that customer service rep going to do right then, do you think?
Follow-up questions to identify which specific screw.
Absolutely. So under this get desired product, we could have clarify with the customer. Maybe the customer is extremely precise and literally has the part number, right? And this get desired product step is done because they're like, oh, you want the product number with a SKU. Do you know the words or the acronym SKU?
Yeah.
Okay, stock keeping unit. You know about that, Brendan?
I do not.
Okay, in the retail industry, any unique product which is differentiated, like it's differentiated even within its own sort of product family, sufficient for inventory control. Like you might say, I have a bicycle of a certain model, and for inventory control, you don't care what color it is.
Okay.
But let's say you do care. Well, then you're going to take that inventory, those bicycles of a specific model, and for every single color in the line, it'll have its own individual SKU. So they call it a stock keeping unit. Think of it as a unique identifier for a product.
Sounds good.
So if they had the SKU, hey, our job's done. And then absolutely what Carolina was saying next is check inventory. That's good. But what if the customer says, I'm not sure. Can you, like, what are the options? I know I want a screw, and I know that it's like 1.25 inches long. What do you have? How is our customer service rep going to find that out?
A filter of different options or by category.
But I mean, if we're talking about the manual process, they don't have a computer program.
Oh, sorry.
Well,
Manual
they don't have our computer program. What tools do you think they may have come up with already to solve this problem? Because it is a problem. How do you think? Go ahead.
I would think that they would have like some sort of Excel spreadsheet again, where they can
Yeah,
filter by screws and
good.
get off them.
So look up in parts catalog. It could be digital, but it could be paper. They could literally have a parts guide. And they have to look in the back at an index and go screws and these, and they go to those sections. They start look for size. It might be even a big giant table, and they've got to scan through till they've confirmed with the customer, we have the exact right thing. So let's pretend for hours that they actually have a digital catalog. They have an Excel spreadsheet, just like Carolina was saying. All right, so they check inventory. Now, how are we going to do that in a manual? Well, I won't see in a manual world. Yeah, in a manual world, no computer program other than, say, simple spreadsheets. How are you going to check inventory?
Manually, like just visually.
Like, good.
Search. Yeah.
Now, if they were going to have in that same digital, in that same spreadsheet, inventory info, not just, hey, you found the exact right product, but how many we have on hand, what kind of things have to happen in the real world so that information is reasonably accurate?
So we have to have created some macros to run that updates
Good.
whenever you have an order, you know, and that updates the spreadsheet. I mean, cannot think of.
So
you
let's say they
know,
don't have that.
So they don't have that. So I guess they have someone who manually once a week does it. Manually.
Good. So this is good. You're exactly right on the manual part. Like literally, someone who has knowledge of the fact that a specific part has left the building would have, or at least has been put in a box. Like, sorry, I can't sell this to anybody else. It's destined for Joe Blow in Topeka, Kansas. Right? Someone who has knowledge of that needs to update the spreadsheet. What's the ideal length of time they would wait before they updated it? Ideally, in a perfect world.
Perfect word, instantaneously.
Yeah, like they take the screw off the shelf and they drop it in the box and they decrement, you know, subtract 1 from the inventory. That would be ideal. Not going to be that easy. Probably in terms of workflow, they would go gather like 15 or 20 things for a big order, put them all in the box, take the list, and then go through and start manually, you know, updating them. So there's a lag, there's a period of time where that spreadsheet is a lie. One more reason why the job we do as engineers helps save the company money, make it more efficient. If we can cause that, you brought up that idea of a macro in, you know, Excel, that's programming. That's why we have jobs. So excellent, good job. So they check inventory. Let's say in this case, what our particular company is doing is they check the Excel grid updated daily. We're just saying that's what they happen to have. Okay, we're making up a fake situation here, but I want to go through this to kind of just, you know, help you think with when we're actually designing a real world app, one, why a company would even spend money. Because here's a real important couple of pieces of data.
Yeah.
Building software is expensive and it takes a long time. I'm not going to be too dramatic about it, but I could probably repeat that about 5 times and it wouldn't really genuinely be enough to get it. Building software is expensive. It takes a long time. Even in really well-performing development houses or development shops. So why do companies do it? Because they make more money by doing it. It's worth the expenditure. And here's a perfect example. Can you imagine if in that intervening time when the inventory was wrong, we oversold and then couldn't deliver. And now we have upset customers and they don't ever use this again. It matters. Okay, good. All right, so let's see. We got the phone call from the customer. We checked if they're existing. If they are, we'll look up their details. That's fine. No, if they aren't, we put them in and now we have their details. If they want to order, well, what do they want to order? I'm going to put get desired products. I'm going to put S in parentheses. Clarify with customer the exact product. Okay, good. So how would they do that? They could, okay, under here is, I'm gonna put down here, get the exact products desired. So clarify with customer or look it up in a parts catalog. And we said that what we do is we look it up in a parts catalog. So I'm actually just gonna, because this is a document that's gonna tell us what we're currently dealing with. All right, so here we are, and we have, I'm gonna put in parentheses, completed building the order. All right, so there we are, we built the order. All right, now what do you think happens in the real world?
Sends the completed order to wherever the parts are to
Yeah,
package the parts.
good.
Don't you have to bill it first?
Say it again.
Don't you have to bill it first?
Woo, look at that. Let's say we don't do billing, people pay right then over the phone. So we'll put that detail right here. We collect a card over the phone. That's what our current practice is. Okay, good. All right, so now it's paid. All right, so we send the order to shipping receiving. That's the right department. Probably a piece of paper. And what happens then?
Sends the invoice to the accounting department.
True. Hold on a second. That could happen. Order and payment info sent to accounting. Excellent thought. Good. So let's say we actually do that. That's in our fictitious company. That's what happens is literally they would like make a copy of it, and they'd pass it down or put it in someone's inbox or something like that. And the accounting department says, "Oh, good. Customer Joe Blow ordered 5 of these screws, and they paid with this credit card." And okay, good, awesome. I'll make a record of that. All right, we're not going to get into the whole order payment part of it. We're looking at the customer service rep. At that point on 5B, they're done with the money part. Okay, so they send it on to shipping and receiving. Now, the customer service rep isn't going to be doing this part, but they need to know what's going to happen next. What would happen next over in the shipping and receiving department?
Need updates on progress.
Well, I mean, in the real world, what are they going to do? You say progress, what's going to happen? What's that shipping personnel going to do?
Alert when the package goes out.
We don't have anything in a box yet. All we've done is sent an order over to them.
Then they will complete that order.
Yeah, assemble the order. They literally have to go get the stuff. Maybe I should actually spell that right. I don't know. It's just me. Good, excellent. Okay. And here, update. We already talked about it, so I'll put it down. Inventory. Okay, good. So this is what currently happens with our mostly manual process, that the ownership of the company is saying, "Hey, we need you guys to build us an app. Here's why. This is what we're currently doing." So they update the inventory, and then the order's assembled, so they ship it, right? It's out the door. What happens then?
Updating for the customer as far as progress from shipping.
Okay, good. So let's say that this is perfect, Brandon. So let's say you're Joe Blow, and 2 days later you call in, you're going to reach a customer service rep. You're not there to order. Same part, same thing applies. They're going to check if you're existing, and you are, so they look you up and they can see, oh, all right, okay, I see the order that you made 2 days ago. I took the phone call. Hi, Joe Blow. And Joe Blow says, what's the status of my order? How is that? And Brandon, you already answered this, but I just want to focus on it. How's the customer service rep going to know what to tell them? We don't have a computer program yet. We do have like digital tools like spreadsheets and stuff, but we don't have a computer program yet.
They can ping the other department and ask. They can call the other department. They can email.
Right. If they have to, ping them, call them in some way, and they're all busy or whatever, you're not going to get an answer. Instead, what we do at our company is right here on assemble. When done, they marked it as assembled. No, they just what we're doing right now, they send a memo to the CSR. That's it. That's how rudimentary our company is. I'm painting a really ugly picture, but it's all too common. So yeah, that morning the CSR starts work and he or she goes through this list and like, oh, okay, here's for that order from Joe Blow from 2 days ago. Oh, good. It was assembled yesterday at about 4 p.m. Okay, good. And they've got that. Now Joe Blow calls in and like, oh, hold on a minute, sir. May I put you on hold? And they're rapidly looking through their papers and they see, and they call them back. I see here that your order was assembled, but hasn't shipped yet. Why do they say it hasn't shipped?
Because they haven't received an update themselves.
Perfect. So right down here, send a memo to the CSR. Okay, good. What's the next thing that happens in the physical universe?
The customer receives it.
Good. All right. So let's say the system we have in place is that while our company may be behind the times with our own internal computer programs, we do have internet access and the web exists. So what happens is that daily, our shipping clerk checks UPS, because that's that we happen to use UPS, for order status. And B, for delivered orders, they send a memo to the CSR. Now, this is a not unreal sort of situation. You guys agree? Like that this could be a way a company was operating right now and still surviving and making money, right?
Sounds like it, yeah.
Okay. So one thing that I'm noticing in this is that from the customer's point of view, the customer service rep is considered to be the source of truth. They can't call that shipping clerk and say, you know, hey, June, this is Joe Blow in Topeka, Kansas. Did you ship my order yesterday? They can't do that. So as we're thinking about building an application, it becomes immediately, clear that what we're creating is a source of truth for the CSR. This is one central location where this entire cycle is able to be tracked. And so at any point in time, they can find out what the truth is about the state of a customer or an order. Does that make sense?
Yeah.
Okay. So one thing that an engineering team would do when faced with a situation like this is, if they're being responsible, they need to first assess, do we really need to build a whole application? Now, in this case, it's pretty clear that the answer is yes. I kind of mocked up a situation where it would be, otherwise we wouldn't be doing this stream because we wouldn't build anything, right? But it is a fair question. Every once in a while, there'll be some sort of project that is being considered, and it ends up not really being a thing that would help a lot. So, or isn't the right thing to do for a variety of reasons. So what's your opinion? I mean, do you think like the company would benefit by building some sort of a tool for the CSRs?
So the kind of discussion we would have is, I guess, we being the engineers, right, would be, is that a good use of our time, or should we outsource this to someone else to build it for us? Or can we?
That's a separate thing. Yeah,
Okay.
That's a real good thing to bring up, Carolina. But who does the actual engineering work? That's a separate discussion, and frankly, is usually made at a level above a typical engineering team.
Okay.
Yeah. Although that's not always true. It might very well be that there are some offshore teams, for example, that you as an engineering team have worked with quite often. And when you look at certain aspects of this, you might, as you start parceling out work, go, you know, this whole piece, let's give it to that team down in Central America or over in India. Totally possible, right? You might even look at it and go, man, this is so similar to what that team did for us last year. They did a perfectly fine job. Let's just hand it off to them. It costs less, saves the company money. And we have these other really urgent engineering things we're working on. So it's actually really cool that you brought that up. It's absolutely something you would kind of think of. Okay, so here we are right now, and we kind of have the current situation. We have it here under existing manual process. And by the way, I want to show you one of the cool things about this markdown syntax. If I right click on the tab and show you what it'll look like in an actual program intended to consume it, I can go preview. And this is what it's going to look like.
Oh, nice.
It is, isn't it?
Oh.
Here we are with a full size.
Where did you click? Where did you click?
I right clicked on the actual
name
text file.
Oh, okay.
And I went down to open preview. And this just shows you what it would look like if you put it out on the web or any computer program capable of reading through this stuff. For example, I've been raving about this Obsidian program that I've been using, which is open on another screen. Let me make sure I'm looking at something that I'm okay with.
You prefer Obsidian or Notion? So I guess I prefer Obsidian.
I happen to like Obsidian. I'm new to it. It's only been 2 or 3 weeks. I'm super happy with it. Okay. Yeah. But any editor should be able to handle it. So if I look here and click on the view is editing, I click to read. Now we see what it's going to look like.
Cool.
Okay. So that's Markdown. Not a vital skill as an engineer, but you're going to be creating and consuming a lot of documentation, and it's a really, really valuable. It's easy to use. It's really nice. All right, so let's just think about this. We all agree as a team that, like, wow, we really do need to build something. And by the way, you may or may not, as an engineer, have been involved in gathering all of this information. It might be that there are business analysts, for example, that already did all this, gathering and organizing of information, interviewing the actual end users, our customer service reps, and kind of writing up, here's our existing process that's primarily manual, that uses actual pen and paper or some Excel spreadsheets, and they would document it with some great degree of detail. This is just a sketch to kind of paint a picture. They would have explicit detail on exactly how the processes work. And it might even be that outside the engineering team, someone else above us has already made the decision that the creation of a custom application is justified. In other words, we might not be involved in this particular exercise at all. Mm-hmm. But sometimes you are. And I kind of want to just go through it to give you a feel for the kind of problems that our applications solve. And when you understand what people are going through manually, what the existing scene is, it gives you some empathy for the user, and also points out some things to think with about the actual program you're going to make. For example, we're seeing that the hub for all of this is the CSR. There are other people involved, accounting, shipping and receiving folks, but the hub for the entire set of functionality or need in the business is the CSR. So we're building a CSR portal or tool.
It has been my experience that at large companies, we normally use either a business person to build that. I have built several of those, or a TPM, so a technical project manager.
Yeah, absolutely.
Yeah.
They would be out in front of the whole project, making it so that when we get to the point where we as engineers need to buckle down and do work, a bunch of stuff has already been done, so we can just get down to putting the basic framework of the computer program there, mm-hmm. and then starting to customize it in accordance with everything that project manager or product manager identified. We can go, oh, good, okay, thank you. You've already documented all the features and the kind of the workflow. Now let me make this happen in code. Oh, you're right. And the bigger the company gets, the more specialization they can have
Mhm.
in those roles. You may very well at one point in your career end up being a consultant where you do all of it. And so that's another reason to kind of look at this part. All right, so here we are, and we've kind of got a good idea of what our existing scene is. Okay, so I think we could start looking at proposed solution. Like we will build an app centered around the CSR. It gives them access to what kind of things will they need to access?
Customer information, specifically their bio information,
Yeah,
address, all that, order history.
good. What else?
Payment information. I suppose that's customer info. But
Good. Let's clarify this then with customer biographical, kind of like name, address, phone, that kind of thing, and not financial. So I would put down here customer payment info. Okay, good. I like that differentiation. What other kind of information do they need to have at their fingertips?
order tracking things.
Ooh, good. Order status. They need to track the order status, so they need that information. So you're on the phone and you tell them you want to order a bicycle. What do they need to do?
Check inventory.
Yeah, so they need access to product info, including inventory. I can't think of anything else they would need to be able to make this all work.
No, it sounds like a good start.
Okay.
Perhaps
go ahead.
perhaps something to where we can add notes about the customer. So like when they prefer the delivery, morning, nights, or something like that, or
Perfect.
who the client it is, or if we need to call back the customer.
Excellent. So look at this for a
So
second.
just notes.
Let's put this under design notes. Place for we call it free form information. It's not an existing form field. Info on customers. What were some of the examples that you listed? I like this.
Preferred time to call the customer back, preferred time for delivered, for deliveries, if there are different people that you talk to with the company, what else? If we have to call them back at X amount, like a specific day.
Excellent. Yeah, it's something. It's not something that we need to create to be a standard part of the.
No, just like for the rep to be able to like input it as
That's
like,
excellent.
To build a rapport, right? So that they can be better serve the customer.
Absolutely. Absolutely. All right. So we're actually going to come right back to that in just a moment here, because it's at this point that you can start to think about a really central part of any program, which is what are the types of objects that this program will work with. There's a fancy name for it, which is either we can call them business objects, and sometimes they're called entities.
Okay.
And we already have a customer. We know that customers will have orders. I'm just reading it from up above on lines 42 payment info is very much, it might be tied to a customer, it might not. Multiple customers might use the same payment info. We know for sure that, now question. We have here on line 45, order status info. Is that its own separate object?
I think
I'm
it
not-
should definitely tie into the. It should definitely tie into what the customer ordered. What are we
Good.
talking about.
This is a really important thing, right? And now I'm going to switch for a second into just strict teaching mode for a second, okay? In computer science, this concept of an object gets thrown around. It's a very loose definition, a thing that has properties and behavior. You have a car and properties are gasoline engine, 4 doors, convertible, that sort of thing. Those are properties of it. Behavior is accelerate, decelerate, turn. You follow?
Yes.
Good. All right. So if we look at that and stack it up against this concept of an order, the order is the thing. One of its properties is its stage in the overall cycle. We know the overall cycle. The order gets created, it gets paid for, it gets assembled, it gets shipped, it arrives. Those are the stages. Now, through all those things, an order is still an order. So you can look at it as an order is an object, whether it is sent or delivered or whatever, that is a property of the object. So order status information is not its own standalone object. It's simply a property of an order. You see that?
Gotcha. Okay.
Yes.
Okay.
Perfect. And all this, yeah, go ahead.
Sorry, Eric.
This
I
is
just
perfect.
wanna back up. Are we talking when you're talking about objects? Are you talking like about objects as in like generally speaking code wise, or is like objects as in like in JavaScript? I was talking like
Just generally in all code, like
All
almost
code.
every program language that I've ever heard of, this is one of the core underlying concepts for all of them, is we're trying to model in our code a real world thing, almost always.
Sure. So then we
good.
have the object, and so kind of like what the way I'm thinking about it is like, okay, so we have functions. So like it would be like the object will be a huge function with functions inside of it. I'm just
Actually,
saying.
no,
Like,
it would be like this. You would have a class, that's an object, right?
whoa,
Called student,
okay.
right? And then in here, you'd have properties. And you'd have behaviors.
Okay.
Now watch this. Properties would be like a string. Well, let's pretend it's JavaScript and we don't have types. It would just be a key value pair. So it would be a name, and it would be a student ID, and it would be an age, that kind of thing.
Okay.
Those are all characteristics or properties of it, right? What does it look like? These have nothing to do with what a student can do. However, what if one of the properties was enrolled status? Are they or are they not enrolled at the school? You might have someone that takes a break. They took a gap year. They went to Europe. Lucky bum. So a behavior might be, would be enroll and unenroll. Those are behaviors. And they might change this enrolled status. They might do other things like communicate with a billing part of the program to say, hey, no longer bill them, they unenrolled. But this is a behavior, not a property or a characteristic. You follow?
Yep.
Good.
Makes sense.
So
Thanks so much.
behaviors in JavaScript and in Python, that's just functions. In other languages, we call them methods. Doesn't matter what you call them. They're just actions that can be taken. So oddly enough, we're going to look here and say we have an object called an order. And one of the properties is status. There you go. And that's what we're talking about here on order status information. Cool?
Yep.
All right. I'm stopping teacher mode. Now we're back to being a development team. Okay, so what other objects? We have a customer object. We have an order object. We have payment information object. What other objects are we going to interact with?
Products and what's an inventory?
Absolutely. An inventory would be a collection of products. So inventory is not its own separate object. Good, excellent.
And I think the shipping status, no? Like something shipping.
Yeah, but a shipping status would also be on an order though, wouldn't it?
Oh, okay, sure, yeah.
Yeah,
Absolutely.
because that you have that thing which is called an order.
Yeah, yeah.
And an order isn't 100% a physical thing that you can walk up and touch. It
Yeah.
is still in the real world, just it's a construct or an idea.
Mhm.
But as you know, as workers at a retail company, we all of us understand what this object called an order is.
Mhm.
It
It's
has
real
many
enough.
characteristics.
Yes, exactly. Okay, so I think we have this. Now, let's look at one little nuance. Let's say that there are two people living at the same address. So you have Eric, who lives at 123 Main, and you have David, also at 123 Main. And so on our customer, one of the pieces of data we're recording is we're recording their address. Now let's say we have two customers. We have a customer named Eric, and we have another customer named David. Let's say that both Eric and David move. They both move to a different house. But it's Eric that calls in. And Eric says, hey, I'm moving. Oh, and David, who I think orders from you, is also moving. You as a customer service rep now need to go into two different records and change it. It's inefficient. Here's the point I'm arriving at. An address is separate from a customer. You can walk up and put your hand on David's shoulder and then walk over and put your hand on a house. They are not the same thing. An address is not a characteristic of a person. It is a separate object. Does that follow?
So you're saying create a separate object solely for address, or separate objects solely for addresses.
Absolutely.
Hmm.
And then, I mean, you could tie them in using the customer's ID number or whatever
Yep.
specific indicator.
Exactly. Customer 5 belongs to address 12. But then all of a sudden, customer 5 moves. We create a new address for him. But do we remove address number 12? It represents a real house.
I mean,
Well,
you just want to update it.
well, do we update the address at all?
No, just the customers.
Exactly. We just tie that customer to a different address.
Yes.
Okay, good. So we now actually have, Carolina, did you follow all that? It's okay.
Yes.
To say, okay,
No,
good.
I'm good.
So we now have 5 objects here. Okay. Let's see how we're doing on some of this stuff. I'm looking back at a previous project like this and just seeing if there's anything we forgot. Yeah, we got it. Okay. So here we are, and we've got these 5 entities. Now, just because of the nature of like how, what we're going to try to build, I don't want to try to build payment information and everything into this at all. So just for the purpose that it will complicate this quite a lot if we're going to build something over about 3 to 6 sessions. So we're just going to pretend that if someone places an order, that's all that's necessary, and the payment gets handled separately. I don't want to build that right now.
Oh, yeah.
Is that cool?
That sounds great.
Yeah, in the real world, you wouldn't be doing that, but I don't particularly want to set up a whole merchant services thing and integrate a payment provider and all that kind of stuff. There's ways to build that out and test it. I might do that in a separate stream. I just want to build an application that can do what are called CRUD operations. Create, read, update, delete. So we have our objects. Now, where you go next on this totally depends on the engineering team. You could start, looking at, well, what technologies are we going to use? Are we need a front end because the CSRs have to interact with some sort of a GUI, some sort of graphic user interface. So we need a front end, and we need a back end where all this data is accessible in a database. Okay. So we can start designing that. What I just kind of like to do now, we as a team have gone through all this thought work to arrive at knowing what our business objects are. And these are the things we're going to model in code. So what I would do next is start examining what those look like. In other words, the properties. This, another word for this is schema. What's the structure of one of these things look like? So this is something I think both of you will actually do really, really well at kind of fleshing out. Let's list them again, right? And let's just start putting in here, what are the properties of a customer?
So name.
Now, is name, both first and last, going to be all combined into one property?
No, you would want them separate.
Why?
Because multiple users could have the same last name or
Bingo.
first name.
Yeah. Okay, good. Absolutely. Okay, good. What other properties?
You would want to give them some type of identification number.
Good.
Phone number.
Bingo.
Order history. So you'd have to jump in, tie it in with orders.
Good. Now, is an order history a property of a customer?
I suppose that would be more related to the order object.
Absolutely, because if we go down to order here, one of the things on it is the customer ID that it was for.
Yeah.
Good thought, though. Carolina, what do you think? Anything else we're missing on the properties of a customer?
I feel like we are, but I'm not sure. Because so we're not going to be doing the address, we decided, right?
Yeah, that's a separate object that we're going to look at in a minute.
Okay. I guess that's it.
Good. Now, if we look at our design notes, you brought up, Carolina, this awesome point. We want a place for free-form information on the customers.
Oh, yeah.
Let's put it in there. We'll just call it notes. Or free-form notes, whatever we want to call it. That's a property. We're missing a really big one.
Yeah.
How many people answer their phone versus answering an email?
Oh, often, yes.
Oh, wow. That was a big one.
There we go.
I suppose you would want an identifying password too.
Ah, okay. There is username
Yeah.
and excellent. Good.
I feel that's about it for customer.
Good.
Yeah.
Now, we're going to switch the order up here a little bit, and I want to do address next for a very specific reason.
That can also be filtered into order history as well.
So what are the properties of an address?
Street number, street
address.
name, street
Good.
address. Yeah.
This is something that's been solved over and over again, so I'll just kind of give you a little bit of this, but at least in nearly all the Western world, the basic schema for this is address line 1 and address line 2. That's generally common enough that we can rely on that and almost everything will work well with it. And mostly your street address goes on line 1, and like any suite or PO box, apartment number goes on line 2. Then what do we need?
City. State or province.
Good.
Zip code.
Zip
Yeah,
code,
and I
yes.
know that in other countries they have different names for it, but it's these essentially there's a very similar construct. Right now, we only do business in America.
Okay.
Just for simplicity's sake.
Yeah.
Don't get me wrong, in the real world, for companies to do business across borders, there's definitely other schema you have to consider, but that nuance isn't going to help us get through the exercise of building a full stack app. So let's not get too deep into it. Okay, good. So here's, go ahead.
Are there tools that automatically check for these specific guidelines in order, address line 1, address line 2, zip code, things like that?
Not-
Depending on the country.
Yeah, there are different APIs you can use, for example, that will take the information you at least have collected and attempt to identify a known address either in your country or some of them actually cover the whole world. Okay. And they'll pull up, is this the exact address you meant? And if you say yes, because it is, then it'll correct, you can use it to correct what you collected. You see this sometimes when you're on a form on a website and you start typing your address and it's like prefetching matches, and then it'll come up and it'll say, you'll have like 2 or 3 below and you'll see, oh, that's mine. And you click on it and it grabs the data formatted the exact way that programmer wanted it to be and inserts that into your form for you. Have you guys ever experienced that?
I think of that through like a food delivery service apps, things like that.
Yeah, exactly. And all they are doing on the back end, they're taking what the person is typing in and they're using one of these services called, this API, application program interface, and they're sending that information and it's trying to find matches from known correctly or precisely formatted addresses and send them back to say, is this what you mean? So we're not going to get into that in this, but that was actually a really, really good question. All right, now, before we move on to order and product, I want to point out something. We have in no way connected a customer to a specific address yet. Now, we're going to get into this later when we start designing our database, but from a very real world standpoint, who belongs to who? Does an address belong to a customer, or does a customer belong to an address?
Customer belongs to an address.
No,
Good.
I think no,
that's
okay.
fine. That's fine. Let's play devil's advocate and think about switching it around when a customer belongs to a specific address.
No, so it's because like we have the customer, we don't care where the customer lives, so the address should belong to the customer.
Good.
Right?
Yes, exactly. So what we need in here as a property is their address. Now, not all of the properties of it, so let's be very precise. A pointer to their address. That just is something we're going to use to say, hey, if I do need information on the address this customer is currently associated with, here's a pointer to that unique address information, to that other object. Does that make sense?
Mm-hmm.
Yes.
Okay. So one of the properties is actually an address ID.
Mm.
Because one of the things we forgot down here is a unique ID, or we didn't think, it isn't we forgot about it. It wouldn't have made sense until we just started to clarify this. So now, because a customer is like, this is my situation I kind of made up off the cuff a few minutes ago, which is, let's say customer 5 belongs to address 12. Right out here, we can say the customer ID happened to be 5, and we see that their address ID is 12. We're going to have many, many address objects. The one with an ID of 12 holds the information for customer 5. You guys follow that?
Yes.
Good. And we're going to see that when we build out the database. All right, we're making really good progress here. And by the way, this particular exercise of building out this schema or these properties, we're going to literally take this exact information when we start making our database. It's going to make it very easy to do so. We know exactly what we want to track for each of these kinds of things, each of these objects, or sorry, these entities. All right, so now let's go down to an order. So what are the properties of an order? We cheated and put down customer ID because we need to know who it's associated with.
Status.
Awesome. What else?
So the inventory information goes there? No.
Oh, yeah. See, no, I like this.
Because that information goes on the product.
Yeah.
The inventory.
Yeah. Yeah. Sorry, moments like that are exactly what I was looking forward to when I thought about doing this. Being able to make that separation and go, oh no, that belongs over there. That was brilliant, Carolina. Okay,
Thank
good.
you.
Yeah, absolutely. All right, so what else for an order? If you're going to write it down on paper, If you're going to literally write down an order on paper, what are you going to write down on that paper? You're going to write down who it's for. We have that.
The amount.
Ooh, love that. Excellent. What else?
I suppose you'd want to keep track of the address ID in which the order will be going.
Delivery address.
Yeah. Oh, talking
Now-
about address, should we clarify delivery address and billing address?
Yes, in the real world, we're going to simplify it and
Okay.
not like billing it and delivery have to be the same. So here's my question is,
Mhm.
on the order, do we need to actually include as properties the delivery address?
Well, it's so that it updates.
Okay, I'm not sure. So we're talking. Okay, help me to understand. We're talking about properties that we're creating objects, and those objects are going to be communicating between themselves, or we have to create for. Okay. So that being said, do we need like some sort of information as well as in like to update the customer page?
Well, let's think this through. Let's say we literally were doing all of this on paper. We're writing down an order.
Okay.
You're both absolutely right. On that piece of paper, we
Mhm.
absolutely need to know where to send this stuff.
Mm-hmm.
You're both totally right.
Mm-hmm.
But in the real world, if it was just paper and pen, where do we go to get the information to write down on that piece of paper?
The customer.
We go to the customer and see that they live at a specific address, and then we grab that address info and put it onto the order.
So you go about grabbing the address ID through the customer ID.
Bingo. And right there, Brandon, that's genius. That is literally exactly how you have to code it out. Because we have the customer ID, we can reach over into the specific customer that we're concerned with. And because that customer has information about the address that he or she lives at, we can now reach over into an address object and get everything we need.
Cool.
That was genius. Seriously. I've seen a lot of people who are who try to start making a real world application, and they don't think that part through. And so what they'll literally do is on an order, they'll have address line 1, address line 2, city, state, zip. They'll have it on there. But now they made a mistake. Somehow the data on here got wrong, or someone moved. Where do you go to change it in your digital record, in your computer program? Do you change it here on the order? Well, no, you'd probably change it on an actual address.
Mm-hmm.
But now in your system, there's a lie about where the person lives. If someone's trying to figure out where to send a thank you card to this person, and they go, oh, I'll just look at their most recent orders. It says they live at 455 Main Street, but they moved over to Jefferson Street. We updated the actual address, but no one remembered to go back and change the order. And so we send out a thank you card to 456 Main Street, and it never arrives. You see the problem?
You want everything dynamically updating.
Exactly. And you want a single source of truth for a specific type of entity.
Recursion.
You should not be looking for information about an address anywhere but on the actual address object itself. If you store that information anywhere else, then you have the possibility of them being out of sync, and now you have a lie in your computer program. Make sense?
Yes.
That was really super well done to both of you to think that through. It was really, really cool. Okay, so let me take away address one. So yeah, so far we know that obviously we need to know what customer the order is associated with. So we need customer ID. For any entity, we need to be able to uniquely identify it. So let's just put an order ID in here like we did for everything else, okay? Does that make sense? Any questions about that?
No, good.
Yeah, we have a, oh, and we didn't do a customer ID, did we? We wrote it down here on line 77, but we didn't give our customer an ID.
It's on the third line. of
Oh,
that.
thank you. Yeah. It's just by convention, I did it wrong.
First, yeah.
Yeah, it's not as if it matters, but put it down on the first one. Okay, we're getting somewhere here. All right, so let's look at this order. We know it has a unique identifier. That's line 76. We know we have to connect it. We have to point to a specific customer because the order is associated with that customer. It's going to have a certain status, you know, created, paid, assembled, shipped, delivered. Oh, right here is where you would start to, what I just said out loud, I don't want to have to go through that process again. I'm actually going to include here on order status the possibilities. Open, and then assembled, and then shipped, and then delivered. And now I don't have to ever think through that again, because we're gonna have to program that, aren't we? All right, what else do you think we need to, you know, what are the properties of an order will we have? Think of if you were gonna, go ahead, Brandon.
It would need to update product inventory.
Right, but that's not a property of the order. That would be a
Okay,
behavior.
yes.
If you had a piece of paper that you were going to write all this down on, there's a vital piece of information that would probably be at the very top of the page that we haven't put down.
Address ID.
I took that away, didn't I? No, we don't need address ID because we have a customer ID.
Customer ID.
Yeah.
Oh,
Let's
I
say,
suppose the address ID.
nope, because we can
It's
reach over to the
customer ID.
customer and get it.
Yeah.
So here's my question. You are a warehouse personnel and you are walking through the office and you see on the ground an order form and you
for the
pick it up.
amount.
We already
No,
got,
it's there.
you know, we already got that. Listen to this question. You pick it up. It's an order form. It's for Joe Blow in Topeka, Kansas. He's ordering 5 screws. Are you going to immediately go out and fill that order?
No, you'd want a time duration, right?
Yeah, some of the timeline with or the date or
Yeah, my central question is, do you, when you pick that up off the ground, know when that order was taken? You just found this piece of paper on the ground.
as of now, no, you do not know.
What if that is a photocopy of an order that was taken a year ago and someone was just cleaning out their desk?
So you want to keep track of the date. It's
Absolutely. We need an order date. When was the order placed? Now, if you're going to be really nerdy, we could also have, you know, if it changed status, what was the date it changed status on? We're not going to get super nerdy and granular, but we absolutely want to know at least when was it placed? For example, what if you want to look at someone's order history? If you don't know when it was placed, you literally can't produce an order history. It's not a history, it's just a random list of orders for that person. Make sense?
yes.
Sweet. So I think, let's see, we have on here for the order a unique identifier on line 76, so we can locate a specific order. We know who it's associated with, who the customer is. And through that, we can get our delivery address. We have a place to record its status. We know how much we're charging for it. We know when we made it.
But we do not know which products.
Bingo.
So we're gonna, product ID.
So I'm gonna write down another property of here, which is list. It's a list. So I'm even gonna put it square here like it's code almost. Those are square brackets. Hello. Product IDs. Does that make sense?
Yes.
We need a collection. It's more, we could have more than one. Now, when we try to solve that and put that into a database, it gets really weird, but we'll solve that when we get to it. Believe me, it's something that's been solved literally millions of times before because it's kind of a lot of e-commerce applications. Good. I can't think of anything else except maybe there's some order notes like beware of dog, don't deliver at 3 o'clock because I'm sunbathing nude in the backyard. Whatever notes you might want to put on there. There's almost always order notes. Again, Carolina was, really right to bring this up earlier. Some free form sort of information that can carry along with the order. And if you were designing a paper order form, you would have presumably at the bottom, any notes about the order?
Wouldn't that tie in specifically to the customer ID and the notes for the customer?
Well, maybe not, because like, what if, for example, the notes in there on the order object, they relate to things that apply for that specific delivery.
Yeah, because I was thinking perhaps the notes in the front are for the salesperson, while the notes in the back are for the driver, for the delivery person.
Here's a super, super, super important one. Let's say that the customer has made it very clear that they absolutely do not want to be called by their first name, and you need to call them Mr. or Ms. or whatever. Stranger things have happened.
Oh, preferred name. We should add that to the top.
Bingo. And honestly, we could get into here to say pronouns. But you see why the notes for the customer relate to that specific human being. The notes down here relate to that process of delivering an order to someone.
Mm-hmm.
So we need two separate sort of areas to put not random, ad hoc, off the cuff information. Okay, we're almost done with our schema. By the way, we're at an hour and 23 minutes in. You guys want to take a quick break? I'd like to. I want to hit the head.
Okay, sure.
All right, let me pull over this. Look what all I did was type ON and look what the very first result is. Tells you how many times as an instructor I've pulled up this online timer. I love this online timer. Oh, wait a minute. Why you give me the wrong one? It's not what I wanted. I don't like that.
Google's messing with you.
It is. For reals. See, that's the one it points you to, and that is ugly. Fine, we'll use another one. Let's take 8 minutes. Is that cool?
Sure.
Yeah.
All right. All right, I'm going to leave this on here so anybody who is watching the stream and steps away knows when we're going to resume. All right, I'll see you all in a I'm back.
Eric.
Hey. Okay, just to let you know how dedicated I am to doing this, there's an awesome steak upstairs my wife cooked. And my wife is an amazing cook. It's not even fair. Like,
I super appreciate you forgoing the steak.
this is fun. I'm liking this a lot. All right, good. Let's go ahead and get rid of this timer that I don't like, and I need to find the other one that I did like. Carolina, you back?
Yes, sir.
Awesome. All right. So we've gotten quite far here. I think the last entity we kind of just want to figure out what it looks like is this product. By the way, I'm so not used to running like this whole Twitch stream thing. I paid no attention to the chat. So if you're watching out there live, I now have the chat pulled up. If you want to throw communication at us, we'll get to it as we can as we're building this thing. So I'll be watching the chat. Okay, so we already know the first thing we want to have. What's the first thing we have on every other entity?
Product ID.
ID.
Good.
Yeah.
Good. What else do we care about on one of these products?
Amount.
When you say amount, like how many of there are?
Inventory.
Yeah, there's a few different ways you can approach this. For simplicity's sake on this, inventory control and everything is a whole can of worms. Fun to get into, but we're just keep it super simple. We're just going to call it inventory. And that just means amount on hand in the warehouse or whatever. Good. What else do we care about?
Well, a description of the product.
Mhm.
Sweet.
Amount, how much it costs.
Good. We'll call that unit price. If someone buys more than one, of course, multiple. Okay, good. What was that weird three-letter acronym that I explained a little while ago?
Code.
SKU.
Oh, SKU.
Yep.
SKU number.
SKU.
Yep. Stock keeping unit. Now we have a description, but what is it we're describing?
The product stuff.
Yeah, we
And
can call
then
it product
also-
or whatever. It needs a name. Like
Yep.
it's a screw. Now the description would be 1 1/4 inches long, this particular thread angle. This is the material it's made out of, whatever. Good. Oh, you were going to say something else, Carolina.
No, that's good.
Okay.
A quantity of product, like oh well, that's inventory. Never mind. I'm
Yeah,
thinking
yeah.
of when the customer's placing it. Excuse me.
Right. Yeah, totally fine. Yeah.
And then perhaps if we could add something under the description that says what it's used for, right? So that should help the salesperson to identify the product in case they don't have this.
A category.
Yes, that's-
Oh,
Yes, thank
this
you.
is awesome. Okay. This is not something that is maybe strictly necessary, but here's the thing. I'm glad that you guys brought this up, because when the business analyst or product manager was doing all of their initial research, this is something they would have figured out, that they would have looked at the workflow for a customer service rep and realized that category helps them find things.
Mhm.
And that when we do like roll up reporting to higher levels in the organization, they like to look at product categories and what the sales figures are on them. And so like, you know what? We need to make this a property of a product. That was a really, really good one. Can either of you think of anything else? I can't. I think that
Yeah.
that would describe a product. So
Yeah.
now again, this last one category brought up a very important point, which is that right now we're thinking up what we think we should track. In reality, there's already an existing process in place, and we would be being told what the properties are of all of these things. Now, they're probably not going to be far off because all three of us are bright and we've bought things before. And so we kind of know what the properties of an order or a product typically are. But just to let you know that, like in the real world, you wouldn't be like coming up with what we think. We would know ahead of time.
Mhm.
Here's the existing process. We need to map this to a digital experience in an application. These are all the things you care about for a customer, for an order, for a product. Cool?
Yep.
Okay. All right, let me go back. I need a better solution here for chat. Like I not that anybody's actually sending anything in. We have people watching, but nobody's sending anything in. I need to pull it off to the side, like take up 50% of the. There we go. That's what I'll do. I'm a genius. Well, not really. All righty. Okay, so now we kind of start, we need to start thinking about like, what are the functional requirements of this thing? What should this app allow people to do?
So then the CRUD things that you said, so create.
Yeah, let's keep
read.
this in mind. Create, read, update, and delete. One thing you could almost always get away with is real simple, like CRUD on every one of our 4 entities. Let's examine that for a second though. So we'll keep CRUD at the top here. So we started with customers. We need to create them for sure, because just like in the real world, if they called in and we didn't have a record of them having ordered, we'd have to take down, what you call it, registered, right? So we need to create a customer. Do we need to read
customer details?
Yeah, let's go directly in the order of those, CRUD, just for convention's sake. We'll
Yes.
obviously need to read customer information from a database somewhere, right?
Yes.
Okay. Do we need to update info about a customer?
Yeah.
Yes.
Okay. And these are choices we get to make. You'll see in a moment here, we're going to make a strategic choice not to do all 4 on one of these. And do we ever delete a customer?
Yes.
Now, that's a business choice. Some businesses will retain a customer record for the whole life of the business. Even if they end up, they don't ever do business with them. There might be legal requirements why you have to maintain that. So that's something that the product manager and the business analyst, those things would have found out for you. Let's say in our instance, yes, we will allow a customer service rep to delete a customer.
Mhm.
Now, a further thing, we're building this application for only one role, a customer service rep, and we're assuming that every bit of functionality in the application, they get full access to. In reality, with a lot of applications, you might have different permission levels that you want for different types of users. You might have a trainee in there. So you have a CSR trainee, and that's one role. And then a CSR themselves is another role. And you could isolate what they have authorization to use. But we're just going to build it for one category of permission level to make it simple. All right, so now we're on to the next entity type. What is it?
Address.
All right, so in the interest of why not use copy paste, which ones of these, if any, do you think we're not going to do?
You're going to do all of them.
Mm-hmm.
Yeah.
I can't think of any reason why we wouldn't. That's good. Let's just pretend our business analyst said, no, you're going to do all of them. All right, what's the next one?
Order.
Good.
And once again, you're going to do all of those.
Yeah. Now, this is the one where I have an opinion just because of the length of time I'd like to spend on this project. I don't think the customer service reps would be entering product information into this system. There'd be a whole separate division of the company.
Or deleting them too.
Bingo.
Or I'd
There
even
we
say
go.
update,
There we go.
updating them.
Exactly. That's all they need to be able to do. Now, that's not technically true because up here on a product, we have the amount on hand.
Okay.
And that can change every
That
time
needs
an
to be
order gets
updated.
placed. So we do need update. Now, honestly, there might be some nuance to it, but we just described the functional requirements of our application. We haven't discussed at all the visual appearance of it, but we know under the hood the kinds of actions it needs to take or implement, right?
Yes.
We're starting to see what this application is going to look like coming together, at least in terms of functions. All right, so there we go. We could start building right now, or sorry, we could start designing, choosing our technologies and building right now. There might be in a real world design situation, there would be a lot of nuance specific to the product and specific to legal requirements and a bunch of other stuff. I think this is enough, honestly, to go, okay, I feel like we should start to decide, yes, we do need to build an application. We have an idea of the 4 primary entities the application is going to work with. We know that it's going to implement, create, read, update, and delete on almost all of them. And we know where we're not. We know we need a front end client for the customer service rep to interact with. And we know we need a back end system that the front end client will call into. Let's start putting together a little bit of the architecture of what this system is going to look like. Make sense?
Yeah.
Yes.
Okay, good. So I want to do that with Visio. I am absolutely 1000% not a Visio expert, but I can make simple basic diagrams, and that's all we really need to do. What is this? Basic I want basic diagram. Okay, good. Okay, so let's start from a high level. We are building a full stack application. So let's pull in 3 different parts here. And this will be the client. We're going to expand this. And then let's copy this. This is the server. That's where our back end is. And this one, I actually don't want to use this symbol for it. We're going to use this symbol because that's a universal symbol for database. All right, so we know we have these 3 parts. Let's start to think about this in a little more detail. So we need to kind of think about what technologies we're going to build here. Now, there might be a lot of discussion involved in that, in an engineering team, because you aren't always going to just be able to choose the exact technologies without there being any ramifications. We're going to choose. We're going to have the front end built in React. Our back end is going to be what's called an API, or application program interface, built using Node and a popular library in Node called Express. It's a web framework. And for the database, we're going to use the relational database called MySQL. Now, we're not going to go through the entire, like, what if there was, this constraint and that constraint, but that's what you're going to encounter when you on the job is, for example, you may not get to choose the database technology because there might be a preferred one at your company. Your company may only do Java development, and you're not going to make, a Node application written in JavaScript if your company says, sorry, we only use Java, for example. Or they may want to use a different front-end technology like Angular. We get to choose because that's what we decided to do when we did this stream. So now let's start to have a little more info here, and let's make some choices here, or let's expand this a little bit. Let's make the client a little bigger and see if we can put some information inside it. So we said client, and then let's put down React. Okay. And then let's make this a little bigger as well. I love that. It shows you when it's the exact same size. It's pretty cool. And so our server, we use node.js and Express. All right. And for our database, MySQL, but I'm actually going to spell it correctly.
I thought you said we're going to use NoSQL, no?
No, we're not going to use NoSQL. I'm not going to use like Mongo or anything like that. I'm going to use relational database.
Okay.
And there's a whole separate discussion we could have about that. But for this particular type of application, an actual relational database is a better choice in most cases.
Okay.
As a whole architectural consideration. All right. So now we're getting even closer. I think I'm going to stack these so we can have a little more room down the page to kind of work with. We'll go down here. Let's see. Again, you can see I'm really not skilled at using this. There we go. Okay, good. So we have our little diagram here. Now, let's look at some of the communication we're going to make between these things, how they're going to interact with each other. So I think I can do arrows. It's not going to be easy if I put them at 45-degree angle to each other. So we'll go like this. Our client, go ahead.
I was going to say, I'm trying to do this using draw.io. I'm suffering.
Yeah, I've used that as well. I'm trying to get a little more skilled at this. So let me take and put another one in here. Did it make two of them? Oh, it's defaulting. Let's see.
It's like you're editing the vector.
Oh. All right, so I have one there right now. Can I move it? I can. Oh, there's some snap to. Let's Google that. Visio. And by the way, this is exactly why I want to do this stream. It's like, hey, you're trying, like, I would want to do this. I'd want to make a diagram. And now I'm using a new tool to do it. I got to figure it out. So Visio snap to grid settings. Turn them on and off. So let's pull this over here, and it says when you draw, resize, move a shape, you set it to a line or snap. I want to turn that off. So shape format under a range. What does this look like? Shape format under a range. So I'll click on this thing. I don't see any shape format.
Top right, the second panel.
Ooh, second panel.
From the right side.
Yep. Oh, you're
line.
Good. Good. It's not in there, huh?
I believe it was under a line.
Huh. Move endpoint. Oh,
Yeah, that's what you're editing the vector itself. So
yeah. All right.
maybe turn it into, I don't know if you can turn it into, say, an object or, you know,
Oh, I
PNG,
see.
whatever.
Oh, cool.
Because I want 2 of these. And I do not
Shift,
want. Go
Shift
ahead.
D, Shift D maybe. Nope.
Nope. Start typing on it. Okay, good. Think here for a
You
second.
learned a shortcut there, though.
I did. That was cool. All right, let's think for a second here.
What are you trying to do?
I want 2 different arrows. One pointing one way, one pointing another. Oh, okay.
Why don't
So
you use the double arrow?
actually here, I remember now there's a whole separate thing about it. Connectors.
Ah, yeah.
Ah. Or you could use the double arrow.
Yeah, I want more control over it. Okay, so there's a connector. Can I do a second one? Nope.
Yeah. Though you have, it looked like it was doing it from the top as well. That's,
Yeah. I won't like it, but it'll communicate. All
Yeah.
right. So if I double click on this, do I get to type? I do. So this will be an HTTP request into our API. And this will be an HTTP, didn't work. Response. Okay. All right. And then here, we're going to have into the database and then back. Wow, you're really going to be. I wish I could just do free form on this. That's really weird that it won't let me do that. Yeah, that's just really odd. Again, I haven't used Visio very much at all, but we know what it'll be. So this is going to be a query, like an actual SQL query that gets sent to the database server. And what we're going to get back is a data set. Okay. I don't like that they come together, but we're communicating it. All right, so we're kind of seeing our system come together a little bit. The architecture of each of these will have to flesh out a little bit. Here's what I would do right now is I like to start with the API right here because it's easy enough for me to send in a request without even having a React client. There's lots of utilities for sending the request in. Lots of them. And so if I build this a little bit, I can check its operation by sending in a request that I know I'm eventually going to make come from the React app. Does that make sense?
yes.
Okay.
Like get all that boilerplate stuff out of the way with Express and make sure you have the connections and
Yeah. Okay. So we'll shortcut a bunch of discussions that a real team would have where they discuss various technologies they could use in each one. And we'll, like I said, we've decided on these ones. So now as say a team lead, I would take it upon myself to create the initial project here. There's 2 projects. There's the front end project, it's its own application, and there's the back end. I'm going to start with the back end. So let's go ahead and start building that out. I'll show you exactly what I would do. Okay. I have a GitHub repo. I would go out to it. Your organization might have one. Let's see. Oh, I don't have a window over here anymore. Okay. I was trying to find one that was actually on this monitor. So let me go to GitHub. And I need a new repository for this project. Now, what did I call this project locally? I think I called it
MERN.
Yeah, learn underscore in underscore public underscore MERN. Okay, so I'm going to make a repository out here just for that.
So can you clarify what a repository is?
Say again.
Can you please clarify what a repository is?
Yeah,
Is
a
it-
repository is a managed collection of text files. And when I say managed, I mean specifically that we keep track of the version of every single file in that collection.
Okay.
The other added aspect of it is it's not just a collection of files that we keep track of the version. It also means that you can create a whole separate copy of it at any point in time and
Mhm.
maintain the history of every single one of those files as well.
Sure.
So you can keep two separate but parallel versions.
Mhm.
And that's what we're going to create is the actual collection, and it'll only have one version to begin with. Those versions are called branches. So we said we were going to call this Learn in Public MERN. I think that's a great name for a repo. I like it. Now, let me show you some options here. You wouldn't be setting this up typically when you first get on the job, but just some considerations. If you're using GitHub, there's lots of other providers to do this on, okay? Like Bitbucket and GitLab and Azure DevOps and a whole, Bamboo. There's a bunch of them, okay?
Mhm.
I just happen to like GitHub. So you can choose between public and private. Anyone on the internet can see the repository. You choose who can commit code changes. So we're going to keep it public, so anybody can look at the work we're doing, okay? Obviously, private is private. We choose who can see it. Now, you could initialize the actual repository with a couple of files already in there. We're not going to do that. We're going to start creating on my local machine, and when I'm ready, I'm going to push that code, those files, out to this repository. That's how I'm choosing to start. We'll talk about what the README and the git ignore are at a later date. Right now, I'm just going to make the repository. And it gives me instructions to push an existing repo from the command line. In other words, if I had a repository on my machine, these are the instructions for me to connect to this remote repository. I just made this repo called Learn in Public MERN. This is how to connect to it from my local machine. This is how to make sure that on my local machine, I've named my main, named my branch the right way. They do that because often, because of the way things were for decades, the branch, when you create the repository on your machine, is called master. And we're trying to get away from using the word master for that. So we rename it. And then you push all of your files out to this thing called origin, which is the remote repository. We're going to do all of this. You'll watch me do it. Okay. But now I want to start by actually making the default basic node project that we're going to use. And again, this is something that would have been done ahead of time, but I'm going to have you watch the way I do it. And then right after that, you're going to get set up so you have that exact same code on your system. I'll leave each of you through that. Okay.
That's good.
All right. So let's go back to Visual Studio Code. And I want to open up a command line right in the folder that I'm at. I've already got a README. Now, I may need to move that, but in this folder, I'm going to make an actual Node app. And like many people, I don't memorize syntax, so I'm looking this up. So it'll give me a minute here.
Would you mind repeating what it is that you're doing right now?
Absolutely. I'm actually making the back end program, the server side program right now.
Okay.
So I'm not going to build any of the actual features that we're going to build. I'm making a default version of it. You first do that by creating just basically setting up the folder we're in to hold a Node application. On my program, on my computer, I've installed Node, which is a runtime. Do either of you know what a runtime is? Can you describe a runtime? It's okay if you can't.
Not specifically, but I have used NPM quite a bit.
Okay. By the way, I teach experienced engineers all day long at some of the biggest companies in America. Many, and I mean many of them, cannot explain or define what a runtime is. And that's fine. So it's totally fine that you don't know, okay? A runtime is a continually running program that can be on a server. And its job is to sit in between your computer program that you're making and the underlying operating system and the resources that your program might need. A typical one that kind of just makes this real for people is file and folder access. In your computer program, probably the last thing you want to do is build how to access file and folders for the specific operating system you're going to install your computer on. Because I don't know if you know this, but files and folders work differently from a Mac machine to a Linux machine. Well, Linux and Mac are real similar in the hood, to a Windows machine. There's variations in how that works. You would have to program in your computer program to determine what operating systems you're on, and just to navigate files and folders be totally different code. It's a pain. And why should you have to do that for every single program you make? Or why should all the developers in the world have to figure that stuff out? No. Make a little teeny program called a runtime. And there's a version of the runtime for the actual operating system. And your program can call into the runtime. And the runtime says, oh, you need access to files and folders. Just tell me what you want to do in whatever language I'm in, I can work with. And I'll take care of making that work on this specific operating system. And there's lots of other things in the operating system and the computer that you get access to, like memory management, keeping track of your variables, connecting to other computers. You don't have to program any of that. The runtime does that for you. So that's a runtime. So Node is just a runtime, and it was built for one very specific, very awesome purpose. The program that it's going to interact with can be written in JavaScript. Prior to about 2009, that wasn't possible at all. The only place that JavaScript was ever run was in a browser, like Internet Explorer or Chrome or Firefox. That's the only place that had an environment that JavaScript code could be turned into machine language and could run. And so some really smart people came up with, well, let's build a program you can install on the various operating systems that are out there, and it can take in JavaScript and make it run. Does that all make sense?
Mm-hmm.
Yes.
Okay, good. That's what Node is. When you install Node, it comes with this little utility called Node Package Manager.
Oh.
And that's what NPM stands for. And we use it for a couple of primary purposes.
But
One of them,
it is something you have to install, though.
yeah, exactly. You have to install that. It doesn't come on like it didn't come on my Windows machine at all. When I install Windows operating system, you don't get Node or NPM out of it.
Yes.
Yeah. So we'll set you all up to do that if it's not set up properly. But right now, what I'm going to use Node Package Manager for is to set up in this directory I'm in, which is called Learn in Public MERN, to just initialize the fact that I'm going to have a JavaScript program here. So you do npm init for initialize, and it's going to ask me several questions about the program I'm going to build. The program is called a package. So let me expand this so you can kind of see what's going on. Why am I not scrolling? What's going on? Okay, good. So I did npm init. It says this utility will walk you through creating a package.json file. In the Node world, this file called package.json is where metadata, important information about your program is kept. It's not the computer program itself. It's information about your program. It says it only covers the most common items and tries to guess sensible defaults. It says you can do npm help init and you get more help. And then it even says use npm install, and then this is meant to be where you type in the name of a package, another JavaScript library, afterwards to install a package and save it as a dependency. Do you guys know what the word dependency means?
Yes, something that relies on something else to function.
Absolutely. The computer program you're about to make is going to rely on this other chunk of code. So it's a dependency. So it says package name, learn in public _ MERN. Yeah, I think that's what we're going to call our project. So I'm just going to hit enter because that's a nice default. Version, this is version 1 of this project. Description, demo project to learn in public. Good. Entry point. Now this is a super important thing. And now I'm going to switch entirely over to teacher mode for a second and then go back to being a developer. There's 5 fundamental elements of any computer program. Doesn't matter what the language, a computer program has to have all these 5 things. The first one is an entrance point. This is what's the very first instruction in the program. We have to start somewhere. The other ones are variables, control and branching statements like if, then, else, or while. Subprograms, also called functions or methods, and an exit point. We need a way to tell the computer, hey, we're done running this program. If you need to free up any resources that you had set aside for it, you can free those up. Those 5 elements: entrance point, variables, control and branching statements, subprograms, and an exit point. That's how you learn a new language. I put a tweet out about that the other day, and I can get you that if you need it. But the point is, we need to designate here in this package.json file that you're going to become really familiar with. When this computer program starts up, where does this runtime thing called Node need to look for the very first instruction? And it's going to look in a file called index.js. Now we could change this to, if we wanted to main.js, or we could change it to foo.js. We can name it whatever we want. I'm going to keep it index.js. That's fine. We're not going to get into testing. We're going to add that part in later on. But you could put in here a command that would run a whole test program that you'd set up to test this program. We're going to do that later. Now, I could put the exact information about my Git repository here. I prefer to do it from the command line afterwards, so I'm not going to put anything. Keywords, if you have a whole bunch of these of programs in your ecosystem, you might want to categorize them by tags or keywords. I'm not going to do that. Author, absolutely. Put me on there. Now, there are different licenses you can release software under. Don't need to be too concerned with this right now. This is something that your company probably has policy on, but you won't be making that decision. So it says, about to write to this exact location. It's our folder, and it's a new file that's going to be created called package.json, and it's going to write this exact content. It says, is this okay? And I'm going to say Y for yes. And now watch, I now have a package.json file.
Cool.
Okay. Now, if we look at it, what's in there? Exactly the content that we saw, but it's nice and readable now.
Can you update, delete, do anything to this file, or is it?
Can I update what?
Can anyone like do anything to this file?
Yeah, absolutely.
Oh, okay.
Absolutely. Demo project to learn in public.
But how do you protect yourself? Because for instance, like the authoritative rows, what if you want to change that? What if someone changed that?
You'll see how change. This is just like any other file in the entire project. It's just text.
Mhm.
We're going to start to add code files. Those are also just text, and they're all going to go out onto that repo. At which point, I'm going to have each of you pull that repo down to your machines, and you can make changes. So how do you protect it from changes being made?
That's a whole. It.
Yeah,
Okay.
exactly. We have to set rules in place for who's allowed to actually, make changes. That's called source control management.
Okay.
Yeah, good. That was a good question. A really good question. Okay, good. So we don't actually have any code in here at all. We've got a README file, which is really just our notes on what we're building. And we have this package.json file that says, hey, listen, when an index.js file does actually exist, that's where you should go to run your program. But it doesn't even exist. So what we're going to do is we're going to start, we're going to use a little utility that'll create a default runnable computer program, and we'll customize it from there. Okay. To do that, we need to install several JavaScript libraries. These are the libraries we're going to use in our application. So we go down here to the bottom here, and we again use that utility npm install. And we're going to use a library called Express. This is a web framework. A framework is a fully running computer program ready for you to customize. A web framework is a fully running computer program ready for you to customize that is designed to accept web requests and send web responses. Good, so that's what Express is. We're also going to use a utility for dealing with databases called Sequelize. This is something that helps us write code to interact with a relational database. We also need another library that helps us interact specifically with MySQL. That library is called MySQL 2. And finally, there's a library related to what's called cross-origin resource scripting. This is really nerdy. It's a specific type of attack against a website. We're going to need that. I'm not going to get into what all that means right now. Again, a lot of this would have been set up by someone else before you arrive on the project. And this save flag, I always forget what this is, so I'm actually just going to look it up right now. What does --save mean? npm let's see, when that's used, it saves all your installed core packages in the dependency section in the package.json. So let's run this, and I think we'll see these go into the package.json. So right now,
it's not actually needed anymore. It's
you know what? That's right. I haven't used it in a while, and it still works.
When you use install.
All right. So watch this. When I install this, what's going to happen is that my computer, well, specifically the npm utility, is going to reach out over the internet and grab a bunch of code. I want to show you where it's getting that code from. Okay, so this is a publicly accessible site called the Npm Registry. And what's stored here are literally millions of JavaScript code libraries. So what are we going to install? Well, we said we're going to install, for example, Express, npm install Express. It's right down here. Let's go look at Express. Search for Express. Look at that. Fast, unopinionated, minimalist web framework. Tells us some information about it. This is what it is. This is a code sample of how to use it. It's downloaded about 20 million times a week. Kind of popular. Information about what version, what license it operates under.
This is a simpler version of, say, using the Fetch API, right?
Yes, because it can both. But here, no, not really. And here's why. This isn't designed to issue HTTP requests. It's designed to receive them.
Okay.
Fetch sends out a request. Make sense?
Yes.
Good, perfect. That was a good question. All right, so there's one, and then we said we were going to install, I think, SQLize, MySQL 2, right? All of those exist out on this website right here. There they are. So when I hit enter on this install command, we're literally going to pull those down. You'll watch the traffic as it pulls them down from the internet. Now this normally goes really fast, but I'm streaming, so it might not go as fast. Oh, wow. We're 20 minutes over. I'm going to let you make the call, Brandon. How much longer do you want to go?
Say finish up whatever it is you're doing. Getting
Okay,
set
good.
up is pretty important.
Okay, good. Actually, it won't be very long for, I'm just going to get it set up here. And then when we pick up again Friday, I'll have you guys pull down the code and run it as well.
So,
Okay.
so we should install Node on our machines and everything, right? Do all the setup.
Yeah, all you need to do is install VS Code if you don't have it.
Oh, I have it. Okay.
Yeah.
But so I don't have to install Node?
Yeah, actually, I was just gonna say install Node. Just go to just literally Google install Node and get the most recent version, and you'll be fine.
Okay.
All right, so let's get rid of that.
There are plenty of tutorials on this too if you have any troubles, Node and NPM.
Okay, thank you.
Yeah. So the technology stack we're using is a super common one. All right, so let's go back. So now, look, I have some more code here, but all I have is it added a folder called node modules. And if we open it, there's a bunch of folders in there that contain JavaScript libraries. I'm going to open it. Look at all these folders in here. Every single one of them contains JavaScript libraries.
Oh, wow.
Like literally, we can open Express. This is the web framework. And it has its own files. And in this library folder, even more JavaScript files. And in this router, even more JavaScript files. We get all this code and all the functions inside it for free. And when I say for free, I don't mean money. I mean, we didn't have to build any of it. It's pre-built. It's maintained by awesome people in the community, and we just get to use it. But we still don't have a computer program installed. We just have a bunch of libraries we could use. So we're going to make a little utility that will actually build a default application. Let me do that. Hold on a second. Actually, we're not going to do it with a utility. We're going to start building it out ourselves. So let's put in a specific file structure. I'm looking at a project I did before for comparison. So give me just a second. All right. So do you understand the concept of a root folder? When I say root,
Yes.
Carolina?
Base folder.
Yeah.
Yeah, the top level folder. So in
Yeah.
in the top level folder, I know I said index.js. I'm going to switch that around a little bit to be more precise. I'm going to make a file called server.js. And this is actually going to be the entrance point. So I'm going to change my package.json, and instead of my entrance point being index.js, server.js. All right. So I have a server.js. What I'm going to put in here is code that will access the Express library that I installed, use it to create a running computer program, specifically a web program that's listening for incoming web requests. All right, so this is pulling in the Express library. I now have access to everything inside the Express library. I'm also going to need a couple of these other libraries that I installed. You saw them on the yeah, down below, right? Now comment.
Are you missing the semicolon?
Semi, yeah. I'm going to create the running web app with this. I'm going to make another variable, well, it's called a const, and it's called app. And what it is I'm going to take the Express variable that I brought in. No, don't do that. That autocomplete always gets me. And I'm going to run it as a function. That one command right there actually creates a running computer program. And I want to point something out. That line 5, is our entrance point for our program because it's the first line of code that can actually be executed. I mean, you can kind of say these, yeah, they reached in and they gave us access to a library. But in terms of doing any real work, this is where it all starts. At this point, after line 5 is executed, I have a running computer program. Now, we're going to configure that program a little bit in a minute, but what I want to do right now is first, I want to make that computer program listen for incoming web requests. And it's going to listen on port 8080. And when it hears anything on port 8080, the syntax on this, you'll get used to it, okay? As soon as it hears something coming in, it's gonna log something to the console. Right now, all I'm doing is I'm verifying that my computer program is up and running. I'm ready to see if this runs. It's a very minimal program, but all I care about is, can I create a running app and have it listen on a specific port? So I can go down here and I can actually start it. A couple ways to start it. I can always take that runtime called node and I can run it and I can point it to the actual code I want it to run. So I can do server.js because that's where the code is. It's this file right here that I'm building, server.js. So I can do that and it'll run the program. Watch. Look at what got sent to the log. That only happened because the program started running. Line 1 was executed. Line 2, we created a running app on line 5, and then we told the app to listen on port 8080, and it is. And we know that that didn't throw any errors because we actually got to line 8. We're only going to go about 3 more minutes. The final thing I want to do is see if it can actually receive requests. So I'm going to do define a route for incoming requests. And I'm going to use what's called app.get. That is if someone sends an HTTP verb in to get some information, and they send it. This is where I define where we're listening at the root level of my application. I'll define, we'll go into all this later on. I'm going to take 2 different objects called the request and the response, and I'm going to then use them in a function. And that function, go ahead.
Does Express automatically make it asynchronous? Or I mean,
No.
We're not quite there yet.
Nope. Yeah, that is definitely going to come up, and we'll hit that. But no, it doesn't automatically do it.
Okay.
We're going to use a whole separate library called Axios for that.
Axios, yes.
So if I receive a request on port 8080, and it's a GET request, then what I want to do is send a response in JSON form, and that response is going to be a JSON object with a key value pair. The first thing is message, and the value is you made it to the root of the app. I want to see if this will work. So I'm going to stop my server again, right down here, Control C, and I'm going to run it again. It says it's listening. Now I need to send a request in. There's a lot of ways I can do that. The simplest is literally by taking a browser and trying to hit port 8080 on my local server. So let's just do that. Here's a browser. There's my local host. It's a local server available on every computer. And I'm going to hit port 8080 on it. And it worked. So I want to show you in the diagram what's actually occurring right now.
Thank you.
In fact, for this one, I don't want you to end off on a bit of a mystery here. So give me just a second here.
I was not really following what was happening, but I did not know how to point out what I was not following.
Exactly. I'll show you exactly what's occurring here. And then we'll demo it again. All right. Now, welcome to Eric's iPad. Here's exactly what's occurring, and then I'll switch and do it again. Come on. Okay. This is Eric's computer. The first thing to know is that on it, built in to every Windows machine or Mac or Linux, is a little server. It's called localhost. Also on Eric's computer is a browser. Specifically, I'm using Chrome. Also on my computer is my application. It is also a running computer program. So all three things you see here are running computer programs. My local, this server has thousands of ports, that's an S, that it can listen on, all these little connections. One of them is port 8080, it's a numbered port. That's a connection in and out of the server. Because of the code I wrote, if I send a request in to this port 8080 on the server, it'll send it on to my application. So I did exactly that. I went to the browser and I tried to go to http://localhost. So that's my local server that you see on the right. And specifically to port 8080 on that server. So the request, which is, by the way, just a text document, that's all it is, got sent from the browser into this port 8080. From there, the local host sent it on to my application. My application has logic that says, if I get a request, which is called a GET request, and I'll show you that in a second, then print off the following. You made it, or sorry, send a response that says you made it to the application, or whatever I typed. Let me go back for a second. You made to the root of the app, because apparently I have awesome grammar. So a response, which is also just a text document, gets sent from my application over into the server, out through the port, back to the browser. This is the response. And the browser takes that text and puts it on the screen of a monitor. Any questions about that? Okay, let me show it to you again. We'll go out here, we'll stop the server. So if I hit Control C, you saw me do that. My computer program is not running right now. This means if I go out here and I try to send this request in, I'm going to hit Enter to send it again. Notice that it's just hanging up. This still has an X. It says can't be reached. Now let me turn the computer program on again by telling Node, hey, go into the server.js file and do what it says. Run the program. The program, the code in here turns on a running web application that is this my app right here. It turns it on, and then it tells it to listen. It sets up a routing, and then finally it tells it to listen on port 8080. The routing says, if I get a request, call it GET request, and there's no other information about how to route it, then please send a response back. Send a response back, formatted as JSON that says this. So let's do that in the browser. I'm gonna hit refresh. Oh wait, did I turn it on? I don't think I turned the app on.
Yeah, you never hit it.
Hit enter. Okay, so now it's listening. Let's go back. We'll hit refresh to send it again. And now I'm getting the response back from my application. To again, go back to the diagram here. What happened is my browser sent what's called a GET request, which is just a text document, down into the local host server that's built into the operating system on port 8080. That request was then sent on to my application. My application went, oh, thank you for that request. Let me compose this little text document and sent it back as a response. It went back to the browser. The browser looked at it and said, oh, there's a message in here. I'm going to show it on the screen. And there it is. There's even more you can get on it. If we right click on this and go to developer tools, you click inspect. We can go to a tab here called network and we can watch this happen. I'm about to click refresh. And when I do, it's going to send a request down to the server. Click. So here's the request. It went to the local host. It went to localhost port 8080. The request, there's about 6 or 7 different types of requests you can send in. You'll learn them. Get, post, put, delete. It's the kind of action you want to do. Here, we just want to get some information from the server. So we sent a get. Now that got sent to the local host server on port 8080. If we go back to my diagram, where did the local host server send it?
To the browser.
No, it came from the browser.
Oh, okay, to the app.
Yeah, exactly. Hold on a
Sorry.
second. No, that's fine. This, look, I don't expect you to know this walking in. It's totally fine. Okay. Again, I train a lot of people, and if they haven't done web development, they've done other kinds of development, they wouldn't have ever had to learn this. All right. So to go back to the browser again, it sent a request in. It's just text. I'll show you what the text looks like in a second. That text arrived at the localhost server, and that localhost server sent it. And now I can't inspect that server. I don't know how to do that. There's probably a way. But that localhost server sends it on to our application. When it gets to our application receives it. It has a get that it got, a get request, and it creates a response. And the response is a JSON object that looks like this. That object gets sent from the application back to the localhost server, and then it sends it back to our browser, and the browser shows that response on the screen right here. There's a lot more to learn about that, but that is what's called the Hypertext Transfer Protocol request/response cycle. That would be something to study before next Friday. You follow all that?
Yes. So
Okay.
now that I have to study.
That's fine. The last thing I want to show you before we end off is to show you that it is literally just text. So let's go into our application here. We'll stop it from running, and we're going to install, well, I've already installed it. There's a little extension to Visual Studio Code that I want to show you. Click on extensions, and I search this thing called REST Client. You'll want to install that, but let me show you how you use it. It's really nifty. I'm going to add a file to our project here, and it's going to be called test.http. Remember, we're talking about the HTTP protocol. In here, I can actually write my requests as text, because that's actually all they are. And I can send them to my running computer program from right in here. Watch. Let's do a request that's a get. And the address I want to send it to is http://localhost port 8080. And I want to send it to the root of the application. There's 2 versions of HTTP that are available for use out there, 1.1 and 2. I'm going to use 1.1. So that's just text. Now, it's formatted with pretty colors, but it's just a piece of text, right?
Sure.
Now let me start my computer program up again. My program is running. And notice that this send request, that is, I can click on that. When I do, that extension that I installed called REST client, it's a little teeny computer program capable of grabbing this text and sending it to the address in the text. I'm going to click send. And now this is the response that it got back. And I want to point something out. Both the request and the response we got are just text. There's nothing magical or awesome or special about them at all. This hypertext transfer protocol that you've been studying and learning about, all it sends back and forth is little text documents. And that's all it is. Any questions?
So can you just confirm what it is that you told us we have to study? Is the HTTP
Yeah, I'll write it on here.
request and
HTTP request / response cycle.
cycle. Okay. Great.
So where we're at, let's just kind of take stock of where we are because we're going to pick up again later. Okay.
Mhm.
We have a pretty good description of what the situation is. In terms of the manual process, we have a bit of an idea on our solution.
Mhm.
An app sent around that customer service rep. They can get customer data, order history, payment info. We're not going to do payment info.
Okay.
Order status, product information, including inventory. Yeah, right. We've figured out what the primary objects or entities we're going to need to work with are. For each of those, we've produced a schema or a description of the properties they're going to have. It's quite detailed, pretty accurate. We even included what the different stages are that an order can go through. We know that we're going to do CRUD on almost all of these entities except for product. And we have a bit of an idea about the basic, and I mean basic architecture. Our front end program is going to be written in React. The back end program is going to be written in Node and a web framework called Express. And we're going to use MySQL for the database. And we even went so far as to create the basic, most basic of that back end program, the server,
Mhm.
the server side program. And that back end program, all it has in it is one JavaScript file that spins up a running instance of a web application, defines for that application what to do if it receives a GET request, and then makes the application listen on port 8080 of the local server. And that's where we're at. So when we pick up again on Friday, even though I haven't built out a whole bunch of stuff on here, what I'm going to have you guys do next is I'm going to push all this code out to that repository we made, and you're going to clone that code down to your machines. And then as I build out this, the just enough of this project that you can both contribute, I'll update and you'll pull down, and so you'll keep in sync with me, okay? And that's just going to give you even more experience on the command line. Wow. Team, we went almost 3 hours. That was pretty cool.
Yeah, it was a lot of information. I mean, yeah. So can you add us to the Git repository already so that we can? I want to take a look at it tomorrow, kind of like review some things. Make sure I understand.
No, but here's why. There's no code out there at all. All of this is on my local machine.
Okay.
It's an empty repository, and I want to keep it that way. I want you to see how we go from because every project has to start somewhere. Where are you
Sure.
going to do it? And what we're simulating here is a very common situation, which is that a senior developer is going to build out the basic framework for people to start with. And then
Sure.
he or she is going to push it out to the repo. And at that point, say to everyone, okay, we're opening the doors for other people to contribute to this. Go ahead and clone the repository. So I want you to be there for it.
Sure.
Is that cool?
Yeah, no, absolutely. I just want to kind of like try to do again by myself.
Oh, try to do
But,
this?
Yeah,
This code? Yeah, perfect. What you should do is this will almost instantly be available to watch again on Twitch.
Sure.
Literally
yeah, the VOD. Yeah,
literally
yeah.
just follow along and do the code
Yeah.
yourself again as well. Cool?
Yeah, absolutely. Thanks so much.
Oh yeah, absolutely. You guys are awesome to work with. I really particularly enjoyed that design thing. And some of the cool things that came out with the points, each of you made really good points that affected how we're going to structure those business objects and will lead to some of the logic we're going to have to build in. So
Sure.
good job.
Okay, thank you.
Yeah, that was great. All right, cool. So we're on again for Friday, 6:30 Pacific, right?
That's correct.
Yes.
Okay.
Would you guys like to start to like a little bit earlier at 6?
Yeah,
Brenda?
let's get on about 6:15 again, just to make sure that all our ducks in a row. I really like that.
Sounds
Okay.
good.
Okay,
Sounds
cool. And we've got our Discord if we need anything. Okay.
Sounds good. Thanks, guys.
Cool.
Bye. Good night.
Bye.
See you next time.
Yep.